In the previous lecture you have seen the neighborhood of a point 0. Now at the place of 0 there might be any number, so this number may be anything. So let us have x equal to a. So there are two neighborhood, that is right neighborhood. We can express that as a plus delta, and here a minus delta. So a plus delta is the right neighborhood of a, and a minus delta is the left neighborhood of a. Now move on to the next topic, that is concept of limit. Concept of limit. Now what is limit and what is the concept behind it? So to conceive the total idea about the notion of limit, three important questions are to be answered, and that what that questions are. First question is question 1, limit of what? Limit of what means what is the function to which we need to calculate the limit. So here question is asking for function. We need to have some function for which we need to calculate the limit. Now next question number 2, that is why evaluate limit? Why evaluate limit? Why? What is the need of limit to calculate? For this question we can have a simple example like fx is equal to 2x plus 1. If we plot for this fx equal to 2x plus 1, fx, so at x equal to 0 this is coming out to be 1, and this is like this, y is equal to 2x plus 1. This is at the place 1, let's say 1 x equal to 1, we have answer, we have the value of function as 3. We have the value of function is 3. You can say for 1 is 2 into 1 plus 1, that is 3. So for to know the value of function at 1, we need not to have the concept of limit. We need not to apply the limit at all. So why we need limit and where we need limit? If we think of the value of function approaches in the neighborhood of 1, can we express this neighborhood of 1? We can only express this as 1 plus delta. So f of 1 plus delta, like right neighborhood. So if you can say that this is, if we have delta tends to 0, this is approaches as 1 plus delta. If we approaches from right, this is 1 plus delta. You can say we approaches from right, you can see this is approaching toward 3. This is approaching toward 3. In the same way, if we approaches from left, that is f of 1 minus delta, this is approaches again from the left. At this point the function has value this, at this point the function will have value this. So as we approaches toward 1, this approaches toward 3. So at this small interval we need to have something that can say about the neighborhood behavior of the function at any point x equal to 1 or at x equal to a. To know this neighborhood behavior, we need to evaluate limit. And there is question number third question. How to evaluate limit? Question third. How to evaluate limit? So for different limit, we have different method, different strategy to solve particular kind of problem. There are algebraic limit, trigonometric limit, exponential limit, and much more. Even for the question number 2, there are some indeterminate form where limit works. There are 7 indeterminate terms. So there are 7 indeterminate situations, you can say. For 7 indeterminate form at which limit works, like first 0 by 0 form, and second infinity by infinity form, next infinity minus infinity form, next 0 into infinity, this is fourth, next 1 to the power infinity, next infinity to the power 0. How many there are? There are 6, and one more, that is 0 to the power 0. So these are the 7 indeterminate situations where we need to evaluate the limit. The limit works. Even let us explain them one by one. So let us have the first indeterminate situation, that is 0 by 0 form. What does this mean? And even in the starting lecture, you can see that we were saying that 0 upon 0 is not defined. Since we already have 0 upon 0 as not defined, so this is not an indeterminate situation. You can say that, sir, this is the 0 by 0 and this is equal to not defined. So this is not an indeterminate situation. Even we can have 0 upon like 3. So this is 0. It is still not indeterminate situation. Even 3 upon 0, it is not defined. And still these three are not indeterminate situation. So what is the difference between these three cases and this? What is the difference in this? Here you can see in all these three situations, this is exactly 0. And here this is not exactly 0. This is like tending to 0 upon tending to 0. That's why we call this as 0 by 0 form. This is not exact 0, and again this is not exact 0. Let us have feel of indeterminate situation. So let's say 0 is like, we can have a number like 0.000001, let's say. You can assume to be very less and it is 0 something, and another like 0 point, another one that is tending to 0 like 001. This is also, you can say, so this is coming out to be 10, and this is a finite number. Even we have expressed this, and situation little bit different. Even we can think of like 0.00002 upon 0.00002. Here you can have 100 zeros, and here you may have 101 zeros. So you can still say it is negligible quantity and tending to 0 quantity, and again this is also tending to 0. Still you can say that here is 10. Even if we have 1 at this place, this can be 20, and this can be any value depending on these situations. So this is the quantity. We can't determine exactly what is gonna be. So this is indeterminate situation. Even this is the number that we have defined, and in tending to 0 there is no such defined situation that is tending to 0 and tending to 0, and where we need to evaluate the things. So I hope you understand, you get the idea what is 0 by 0 form, and this is the indeterminate situation. Let us move on next indeterminate situation, that is infinity by infinity. Infinity by infinity form. Again here you can say, assume this is very large number. Indeterminate situation, this is tending to infinity, tending to infinity, very large number upon very large. It can be any ratio. This ratio can be anything. This can be 1, 2, 2000, 2 lakh, or even infinity as well. So we can think of like 2.01 into 10 to power 1 lakh, let's say 10,000, and okay, 10,000. You can think of this number is very large number, and even infinity is much more than this number. And another infinity, that is like 20.1 into 10 to power 10,000, like this. So what you are getting here, you will get 1 by 10. This is the ratio. If you change this, this will change to different number, but that would be a precise number. But this is the number that you have exactly written, and this is not a exact precise number. This is tending to infinity and much more than this. So infinity by infinity may be anything here. So this is the indeterminate situation. Let us move on to the next indeterminate situation, that is infinity minus infinity form. This is also a indeterminate situation. We have here indeterminate situation. This can be anything can be like 2 into 10 to power 1 lakh, or even more. There are 7 zeros plus 1 minus 2 into 10 to power like this. So what you will get? 1 here. Again we already been defined, this is, we define this to be a particular number, and this is little bit different from this, but you have the meaning, same meaning here. This is very infinity, very large number. First one is very large number. This is again an infinity form, and there is something. That's why we have this as a indeterminate situation. The same way, another indeterminate form is 1 to the power infinity. So how is it indeterminate situation? How we can say that this is an indeterminate situation? You already been seen that if we have a number like 1 to the power 3, this is gonna be 1. 1 to power 0, this is 1. 1 to power 100, even this is 1. And how it is indeterminate situation? Again we are not talking this is exactly 0. This is tending to 1, and this is tending to infinity. So there might be two situations. This one may be 1 point something, 1 point something, like 1.1. This is, I have already been looking, this is greater than 1. So we can have, let's say, 5. So let us have the value of this 1.1 to the power 5. This is coming out to be approximately equal to, this is approximately equal to 1.6. Even 1.1 to the power, let's say, 10, this is approximately gonna be equal to, let us have this value as 10. This is gonna be 2.59. I am calculating it by calculator. You can also apply it your electronic gadget like mobile phone and others to get this value. 1.1, if we are calculating the 100, this is gonna be approximately equal to 1 to the 1.1 to the power 100. This is gonna be equal to 13780.61. So you can see that as this power is approaching, this number is becoming large and large. So as 1.1 tends to infinity, this infinity, this will tends to infinity. Now if we think of a number that is less than 1, so that may be like 0.9, let's say 0.9 to power 5. This is gonna be equal to 0.9 to the power 5. This is gonna be equal to 0.59. Even 0.9 to the power 10, let's say we are thinking, so 0.9 to the power 10, this is coming out to be 0.34. And if we have 0.9 to the power 100, let's say, so 0.9 to the power 100, it is coming out to be 2.656 into 10 to power minus 5. You can see this number is decreasing and moving towards 0. So as 0.9 to the power are now tending to infinity, this is tending to 0, towards 0. So this is also an indeterminate situation. It can be go either infinity, it can be go even 0, and it can also go toward any particular number as well. Let us have next indeterminate situation, that is infinity to the power 0. Again, this is tending to infinity and this is tending to 0. Even you can say you can have 1 to the power 0. This is exact 0 is 1. To the power 0, this is again 1. To the power 0, again 1. So you may be thinking of this is also tending to 1, but this is not the actual situation. This is tending to infinity to tending to 0. So this is tending to infinity, this is tending to 0. This may be some tending to some finite number maybe. So this is also an indeterminate situation. And next indeterminate situation, we have 0 to the power 0. We can have this next indeterminate situation, 0 to the power 0. Even for exactly 0 to 0, you can say 0 to the power 0. What is 0 to the power 0? You can get this number by using your mobile phone or electronic gadget like calculator. This is always 1. This is defined. There might be situation that some calculator shows it is equal to 0, but it is defined 0 to the power 0 equal to 1. This is correct. Even 2 to the power 0 is 1, and 0 to power 3, this is 0. These are exact 0. So these are the quantity, these are the number that we need to know. So we are getting here, 0 to power 0, this tending to 0, tending to 0. So this is also a indeterminate situation. So we need to work on these indeterminate situation. One more indeterminate situation we have, that is infinity into 0, that is tending to infinity, this making very large, and tending to 0, this is very very small quantities. By multiplying this can be tends to any finite number. So these were indeterminate situation. These were 7 indeterminate situation where limit work, where we limit make a decision, limit calculate a particular number for us. Thanks.